Hello, welcome to this lesson of our study of calculus 1. All right, so if you have not subscribed to my channel, kindly subscribe to support the channel. Okay, so we just go through some series of questions on implicit differentiation and also parametric differentiation. Okay, all right, let's start. So with the first question, if y squared plus 2x equals 1, then you're supposed to find dy dx. Okay, so what you have to do here is that we are considering this whole function as an equation where y depends on x. So y is a function of x. This is what you should know. We don't know what kind of function y is of x. Okay, so y is actually a function of x, but we don't know the relation between y and x. I don't know if you understand. Maybe y can be equal to something, okay, but we don't know that function. So we assume that y is actually a function of x. All right, so with this, all I have to do is use chain rule. If you remember, I said that in the chain rule, if you have a function, let's say y, which is equal to u, and u is also a function of x, then if I want to find dy dx here, then what I have to do is first find dy du, if you remember, times du dx. Okay, I don't know if you remember this. Okay, so here all that we are saying is that it's not y, which is a function of u, and u is also a function of x, but here y is simply a function of x. So what you have to do is, with a function like this, y of x, if I want to find dy dx, then I have to find dy dx. Okay, that I don't know. Then I find the function. Okay, so we have to find a function d of y of whatever that you are talking about, whatever that term you are talking about. Okay, so I will differentiate y with respect to that whatever that I have there. Okay, so let's start doing this example and you understand what I'm trying to say. Okay, so what I'm trying to say is that, okay, given y squared plus 2x equals 1, okay, you have to differentiate every term of this equation just one like that. So in differentiating the function like this here, all that I have to do is, first of all, find the derivative of dy dx. Okay, but here there's no x here, it's just only y. Okay, so if you remember, I said that if y is equal to u to the power 2 and u is also a function of x, then I want to find dy dx, I have to find what dy du times du dx. Okay, so here what you have to do is simply differentiate this with respect to y. Okay, and you get what? The same idea that you differentiated this with respect to u. Then again, here u was actually a function of x, but here the y is also a function of s again. So what I have to do is find dy, differentiate this with respect to y. Okay, and I'll have 2y times, then I differentiate the y, which is a function of x, with respect to s, so I'll have dy dx. Okay, simply wherever I see y, when I differentiate y, attach dy dx to it. Okay, plus, then I differentiate this with respect to x, because we are differentiating every term with respect to x. Okay, so when I have 2s differentiated with respect to s, I'll get 2 equals, then I differentiate the 1 here with respect to x, and that is a constant, and when I differentiate the constant, I get it with 0. So I have 2y. Okay, I'll have 2y dy dx is equal to -2. So in effect, if I make dy dx a subject, it's like the dy dx is equal to -2 over 2y, which means dy dx is equal to -1 over y. I hope this is okay. This is very simple like that. Okay, so let's go ahead and do other stuffs. Okay, I hope it was okay. All right, so let's start with the main things. Okay, now here what we have here is 3y, or 3s squared rather, 3s squared y minus 2y equals 5. So what you have to do here is differentiate this, and now when you're differentiating this, you treat them as a product rule, because here x squared is a function of x, is in terms of x, but we are saying that y is also a function of x, so you have to differentiate the y. So what we'll do is just write 3, then you differentiate s squared y as a product rule. So in the product rule, if you remember, you said that you have to first differentiate the first one, which is the x squared. Differentiate, you get 2x, multiply the second function to it, then plus, keeping the x squared, then differentiate the next function, which is the y. Okay, when you differentiate y with respect to y, you get just 1. Okay, so you get times 1 times, then you keep dy dx attached to it. So like that, whenever you're differentiating y, you have to attach a dy dx. Okay, so that will be the differential for the first part. Then minus 2 times the differential of y, which is dy dx. Okay, equals 0. Differential of 5 is 0. So I have to get 3 times that. I'll have 6xy plus 3s squared. Okay, dy dx minus 2 dy dx. Okay, so all that I have to do is just make dy dx the subject equals 0. Sorry, so I have to take 6sy to the other side, and then also factor dy dx out. Okay, so I have 3s squared minus 2 out, then dy dx like that is equal to negative 6xy. Okay, so what I have to do is just dy dx equals, divide both sides by 3s squared minus 2. Okay, so I have 3s squared, sorry, the other part was what, minus 6sy. Okay, so minus 6xy over, there was a 3s squared minus 2 here. Okay, so 3s squared minus 2. Okay, so you can keep it like this, or you can also rearrange it and say that this is the same as saying dy dx is equal to 6xy, then the negative will affect this. Okay, I'm explaining this to you because this is the same as, negative of that is the same as saying that this is being multiplied by, sorry, I can clean this negative for the first part and say it is the same as this 1 over negative 1. It's the same thing. Okay, so this affects that, and I'll have 6xy over 2 minus 3s squared. Okay, this can be the answer, or this one. Okay, where with this, where the negative is at the top there. Okay, like this. Okay, so it can be this one or this one in your option. So just look at it carefully and know which answer you are going in for. Okay, and especially when it is an MCQ question, you just try to simplify it as well and see if you get your answer there. Okay, and the third one is, if y squared plus s squared equals 1, find dy dx. So here, very simple like that. I have to differentiate y squared with respect to y. I'll get 2y, then I attach a dy dx to it. Okay, plus 2x equals 0. Okay, so I have 2y dy dx equals negative 2x. So dy dx is simply equal to negative 2x over 2y, which is equal to negative x over y. And it can be x over negative y. That is okay. All right. So that is it for this solution. I hope you understand the implicit. Now let's go to what we call the parametric differentiation. Okay, so here we've been we've been given y, which is equal to 2t squared plus t, and x, which is equal to t cubed minus 4t. And the question here is, you are supposed to find dy dx. Okay, now to find dy dx, what you have to do is, first of all, find dy dt. Okay, sorry, dy dt, and you get 4t plus 1. It's just the normal differentiation, you know. Then you find dx dt. Okay, and that too will give you 3t squared minus 4. Okay, I hope you're okay now. So now let's look at this. I have dy dt. Okay, and I have dx dt. If I want to find dy dx, what should I do? Let's try to divide dx dt or dy dt by dx dt and see. Okay, we treat this as a fraction. So this is the same as dy dt in fractions, dy dt times dt dx. Okay, and so it means that this dt can take this dt out, and we'll be left with what? Dy dx. So in effect, it means that dy dx here is actually equal to dy dt, all of it divided by dx dt, because that's the only option that will give us dy dx. Okay, so here in our solution we had dy dt to be what? Okay, dy dt is equal to what? So you go back and check. Dy dt is what? This one, 4t plus 1. Okay, so 4t plus 1, and the x dt is also equal to what? 3t squared minus 4. Okay, 3t squared minus 4. Now we said dy dx is equal to dy dt over the x dt. Okay, so this whole thing will be equal to dy dt is what? 4t plus 1 over the x dt is also 3t squared minus 4, and you are done. This is very simple, right? Okay, so that is dy dx. Okay, now let's move on to the next one. We have y, which is equal to, y here is equal to 2 cos t, and x here is equal to t squared plus sine t. Okay, so here if you want to find the y dx, you have to first what? We said dy dx is equal to dy dt, okay, all over the s dt. Okay, so want to find dy dt. Okay, and dy dt will be equal to, we have just 2 there. So when you differentiate cos, in our first video we talked about differentiating from first principle. When you study that when you differentiate cos, you get negative signs. We have minus 2 cos, or sorry, minus 2 sine t, and then dx dt will be equal, differentiating them term-wise. So when you differentiate t squared, you get what? 2t. Then differentiate sine t, you get cos t, so plus cos t, like that. So it means that dy dx will simply be equal to just dy dx will simply be equal to just dy dt over that, and that is minus 2 sine t over 2t plus cos t. I hope that was it. Minus 2 sine t was, yes. So that is it for dy dx. Okay, I hope this is very simple. This is very, very simple. So thank you, and don't forget to subscribe to my channel. See you next time. Okay.